Hello friends, my name is Anurag Mahajan and I am from AITR Indore, and my topic is high dimension data, dimension reduction and parallel coordinates. High di Now let's talk about what is high dimension data. High dimension data refers to the data that has a large number of dimensions or variables that define its characteristics. It means the high dimension data have very large number of dimensions. Higher dimension data in computer graphics can pose changes for rendering and manipulation, as the large number of directions can make it difficult to visualize or manipulate the data in real time. Now, what is dimensionality reduction? Dimensionality reduction is a process of reducing the number of features or dimensions in a dataset while retaining as much information as possible. It means it is a process of reducing the high dimension data. This can be done for a variety of reasons, such as to reduce the complexity of model, to improve the performance of a learning model, or to make it easier to visualize the data. It can be used to visualize the data, improve the performance of an algorithm, or to reduce the complexity. Here it is the diagram in which the three-dimension data can be reduced to two-dimension data. You can see this. Now, components of dimensionality reduction. Dimension reduction have two components: feature selection and feature extraction. Feature selection, in feature selection we try to find a subset of the original set of variable or feature to get a smaller subset, which can be used to model the problem. It usually involves three ways: filter, wrapper, or embedded. It means in feature selection we can find the subsets of a given set of variables or features. Now, feature extraction. This reduces the data in high dimension space to a lower dimension space. Example, a space with lesser number of dimension. It can reduce the feature extraction, reduce the high dimension data to low dimension. Now, methods of dimension reduction. There are various methods of dimension reduction. It includes PCA, LDA, and GDA. Now, PCA is principal component analysis, LDA is linear discriminant analysis, and GDA is generalized discriminant analysis. In this video, I am going to explain the principal component analysis. Now, what is principal component analysis? Principal component analysis, we generally try to make our high dimension data to low dimension data. The PCA is an unsupervised learning algorithm that is used for the dimensionality reduction in ML. PCA generally tries to find the lower dimension surface to the project the high dimension data. PCA works by considering the variance of each attribute because high attribute shows the good split between the classes and hence it reduces the dimensionality. Some real-world application of PCS are image processing, movie recommendation system, optimizing the power allocation in various communication channels. It is a feature of extraction technique. So it contains the important variable and drop the least important variable. The PCA algorithm is based on some mathematical concepts such as variance, covariance, eigenvalues, and eigenvectors. Some common terms used in PCA algorithms is dimensionality, correlation, orthogonal, eigenvectors, and covariance matrix. Dimensionality is the number of features or variables present in the given dataset. More easily, it is the number of columns present in the dataset. It means dimension is the number of columns. Correlation, it specifies how strong two variables are related to each other, such as if one changes, the other variable also gets changed. The correlation value ranges from -1 to +1. Here -1 occurs if variables are inversely proportional to each other, and +1 indicates that variables are directly proportional to each other. Correlation is it shows that how two variables are related to each other. Now orthogonal, it defines the variables are not correlated to each other, hence the correlation between the pair of variables is zero. Orthogonal means no correlation. Now eigenvectors, if there is a square matrix M and a non-zero vector V is given, then V is the eigenvector if V is the scalar multiple of V. Now covariance matrix. A matrix containing the covariance between the pair of variables is called the covariance matrix. Now algorithm. Step for PCA algorithms. Number first, getting the dataset. First, we need to take the input dataset and divide it into two subparts X and Y, where X is the training sets and Y is the validation sets. Now, second point is representing the data into structure. Now, we will represent our dataset into structure, such that we will represent a two-dimensional matrix of independent variable X. Here, row correspond to the data item and the column correspond to the feature. The number of column in the dimension of the data. Here we can represent our data. In second point, it says that we have to represent our data into row and column format. It means matrix format. Now standardization of the data. In this step, we will standardize our data set, such as in a particular column, the feature with high variance are more important compared to the feature with low variance. If the importance of the feature is independent of the variance of features, then we will divide each item into in a column with a standard variation of the column. Here we will make the matrix of Z as Z. In this point, we can compare the two variants, and if these variants are independent to each other, then we can divide our data. Now calculating the covariance of Z. To calculate the covariance of Z, we will take the matrix Z and will transpose it. After transpose, we will multiply it by Z. The output matrix will be the covariance matrix of Z. Here we have to calculate the covariance matrix in the fourth point. Calculating the eigenvalues and eigenvectors. Now we will need to calculate the eigenvalues and eigenvectors of the resultant covariance matrix set. I have explained the eigenvalues in the previous slides. Eigenvectors or the covariance matrix are the direction of the axis with high information, and the coefficient of these eigenvectors are defined as the eigenvalues. Now sorting the eigenvectors. In this step, we will sort the eigenvalues. Now calculating the new feature or principal component. Here we will calculate the new features. To do this, we will multiply P matrix to Z in the resultant matrix Z. Each observation is the linear combination of original feature, and each column of Z matrix is independent of each other. Here columns is independent of each other, but the row is dependent. Remove less or unimportant feature from the new data set. The new feature set has occurred, so we will decide here what to keep and what to remove. It means we will only keep the relevant and important feature in the new dataset, and unimportant features will be removed out. Now in this point, in this step we will remove the unnecessary data and take only the important data from the and make the new dataset. Now application of principal component analysis. PCA is mainly used as a dimensionality reduction techniques in various AI applications such as computer vision, image comprehension, etc. It can also be used to find the hidden patterns data if data has high dimension. Some field where PCA is used are finance, data mining, and psychology. It means it is used in data visualization. Now, advantage of dimensionality reduction. Dimensionality reduction helps in data comprehension and hence reduce storage space. It reduces computation time. It also helps to remove the redundant feature if any. Disadvantage of dimensionality reduction. It leads to some amount of data loss as we are using the data extraction techniques. PCA tends to find linear correlation between variables which is sometimes undesirable. PCA fails in cases where means and covariance are not enough to define datasets. If the covariance is not enough to define dataset, then our dimension reduction techniques will fail. We may not know how many principal components to keep in practice. Some thumb rules are applied. What is parallel coordinates? Now, third topic, parallel coordinate. Parallel coordinate is a technique used in computer graphics to visualize and explore high dimension data. In parallel coordinates, each data point is represented by a polyline that intersect a set of parallel lines or axes, where each axis represents a different feature or dimension of the data. Parallel coordinate provide an efficient and intuitive way to explore and analyze the component dataset. By visualizing the data in parallel coordinate, patterns and relationship among different features can be easily identified. Moreover, the technique enables the identification of outlier, cluster, and trends within the data. It means the parallel coordinate is a technique to visualize the high dimension data. It can be represented by polylines which can intersect each other. In computer graphics, parallel coordinate can be used in a variety of applications, including specific visualization, data analysis, and information visualization. As I said, parallel coordinates is used in data analysis and data visualization. For example, parallel coordinate can be used to visualize multi-dimensional dataset in real-time simulation or to explore or compare the performance of different algorithms. Additionally, parallel coordinates can be used to visualize high-dimensional data in virtual reality, enabling user to interactively explore and analyze the data in an immersive environment. Overall, parallel coordinate is a powerful technique in computer graphics that enables visualization and exploration of high dimension dataset, providing insight and understanding of complex phenomena. Here is the syntax in of parallel coordinates. First we have to import the libraries in Python. Then we can use this parallel coordinate formula. Parallel coordinate data in this it have uh, four parameters: data frame, dimension, label, and range color. That's all. Thank you.